Hello everyone, my name is Kendrick and I'm from class 12 IPAA, and today I'll be showing you guys applications of physics that I can find around my house. Now let's get started. First of all, before we start touring around the house, I'm going to show you guys a really simple application of optics. Can you guess what it is? Yes, of course, it's my specs. Because I have myopic eyes, the concave lens of my glasses will refract or bend any incoming light and adjusting them so that it reaches right on my retina for me to see things more clearly. Other than my specs, we could also find several applications of optics and refraction on a couple of common items such as a phone's camera lenses or even a magnifying glass. You must be wondering, how is even opening a door related to physics? Opening a door involves an application of physics known as torque. So, what does torque mean? Torque refers to the rotational equivalent of a linear force, which means it is the force acting on rotating objects.
When we are opening the door, we apply forces to the door handle in order to unlock it. As we apply forces to the handle, it will then move downward with respect to its axis of rotation. Same thing applies to the door hinge. As we exert force into the door, it will rotate along the door hinge, causing it to open and fit us in. Have you realized that when we push the door closer to the hinge, the more force that we need to exert? This is because the formula of torque is the product of the force exerted and the radius of rotation, causing the force to be inversely proportional to the radius. Hence, the smaller the radius, the more force we need to exert and vice versa. This is why the doorknob is always located the furthest away from the door hinge.
Have you ever felt hungry and wanted to grab a quick meal right away? Putting the food inside the microwave is probably one of the fastest ways possible compared to traditional gas stoves. How can the microwave oven heat up a plate of refrigerated food in just a short amount of time? The microwaves produced by the magnetron inside the microwave ovens are directed towards a spinning propeller made of metal. One of the properties of microwaves is that they are reflected off from metals. And so, they reflect off the styrofoam and into the oven chamber. The oven chamber is lined with metals so that the microwaves will continue to bounce around in the chamber until they are absorbed. The bouncing microwaves will then be absorbed by some of the chemicals in food, most optimally water. This is because water molecules are polar, meaning that the distribution of charge within the molecule is not symmetrical. One side of the molecule is slightly positive and the other is slightly negative. Thus, in the presence of the electric field component of a microwave, a force will be applied to both dipoles of the molecule, which will cause it to rotate. Because the electric field is continually oscillating, the water molecules continually rotate. The frequency of microwaves, which is 2.45 GHz, is optimal because the time it takes for the electric field to oscillate is consistent with the time it takes for the water molecules to rotate 180 degrees. Thus, the water molecules are rotating as quickly as possible. As the water molecules rotate, they bump into other molecules surrounding them and transfer some of their kinetic energy. By the kinetic particle theory, if the particles in the food have more kinetic energy, then the food will be hotter.